Yes, good afternoon, everyone. Welcome to the class. Yes, Arpit will be uploaded. I have sent after immediately class is completed. Concerned person I have sent already will be uploaded. There might be a technical issue for uploading. Will be uploaded. Yes, Sahil will be uploaded. Ashutosh Kedare. Wait, you are going to see. Yeah, Ananda, I'll give you that information. Ashutosh, please wait. Why you are that much curious about that? 3 times. Right? We are going to see. Do you have any important works? Okay, right. So what we have discussed in last 2 days is basics of number systems, converting from one number system to another number system, then calculating base values for given equation, then getting complements of respective number system. If radix is R, we can have R's complements, R minus 1's complements. We named it as radix complements, diminished radix complements. Then we have seen signed number representation in binary. How do we represent numbers in binary when we have both positive as well as negative numbers? That's what we have studied, signed magnitude, 1's complement and 2's complement representation. Rules of each and every representation also discussed. What is the range of n bits using each and every representation, and which one is preferable and why? All these points we have discussed. And after that, what is overflow? What is sign extension property? Important things we have discussed. Go through those once again. Try to recollect the concepts we have discussed on same day if possible. So go through the concepts we have discussed on same day. You may be recollecting the information near to 100%. So what we have discussed, the advantages of two's complement representation. Then sign extension property. What is sign extension property and how it can be used? Also we have discussed. And with that sign extension property, what was the possibility of eliminating overflow? Also we have discussed. Right. Now, not on a question, find signed magnitude Nagalingeshwar Rao. What happened? Signed magnitude, comma, one's complement and two's complement representations of minus 87 decimal using 8 bits. Find signed magnitude, one's complement and two's complement representations of minus 87 decimal using 8 bits. What should we find? Minus 87 decimal representations in signed magnitude, one's complement and two's complement representations. So let us see how to solve this question. What is given? Minus 87 decimal. Minus 87 decimal. We would like to find. Then what should I do? Sign to magnitude. Sign plus magnitude. What is sign? Minus. MSB should be 1. What is the magnitude we have? 87. Let me get a binary equivalent of 87. 2 4s are, 2 3s are. Remainder is 1. 2 2s are, 1s are. Remainder is 1. 2 1s are. Remainder is 1. 2 5s are. Remainder is 0. 2 2s are. Remainder is 1. 2 1s are. Remainder is 0. Then what is the magnitude we are getting? 1 0 1 0 1 1 1. What is it here? 1 0 1 0 1 1 1. So here if you are observing clearly, what is this sign? What is this magnitude? Sign plus magnitude. What is this now? Minus 87 in signed magnitude representation. Signed magnitude representation. It is a signed and two's complement representations of minus 87. Right. Is it audible now? Is it visible? There was a problem. I think it was disconnected again. I connected. Venkanna, I won't do intentionally, right? Yes. Okay. Right. Yes, sir. What is the question? I need to represent minus 87 decimal using 8 bits, sir. The first one we have done, sign to magnitude. What is it here? Sign plus magnitude. Sign plus magnitude. So, sign, we have represented minus with the 1. We have represented sign with 1 because it is a negative number. It is a negative number. Yes, sir. It is minus MSB is 1 and magnitude which if you are observing 10101111. It is a magnitude. So it is sign plus magnitude, sign to magnitude representation. How many bits we have used? 8 bits. So MSB is 1, sign is minus And here 7 bits required for magnitude. So it is used 8 bits as expected. Now I would like to get minus 87 in 1's complement and 2's complement representations. For that, first let me represent plus 87 using 8 bits. So plus 87 using 8 bits plus 87 is 101011. What is this here? Plus 87 in which representation? In all 3 representations. Be clear about this. It is plus 87 in signed magnitude, in 1's complement, and also in 2's complement representation. It is a plus 87. I want to get minus 87 in 1's complement as well as 2's complement. How to get that? Let me take 1's complement of this. What we get? 101, 01, 0, 0, 0. It is a minus 87 in 1's complement representation. 1's complement representation. If I want to get minus 87 in 2's complement representation, what can I do? Let us take 2's complement of this positive number because it is plus 87 in 2's complement representation also. If I take 2's complement of this, I will get minus 87 in 2's complement representation. What we get here? 1. Taking complements of all the bits. I hope you are following. Everyone is following the rule which I mentioned. 1, 0, 1, 0, 1. So it is a minus 87 in 2's complement representation. 2's complement representation. First we have represented plus 87. How do I represent that? Plus MSB is 0, remaining bits magnitude. If you are representing that, it is plus 87 in signed magnitude, in 1's complement, in 2's complement. Already we have discussed. As these are positive numbers representation is same in signed magnitude, 1's complement, and also 2's complement representation. Right? So if I am representing positive number in any one of these representations, that is correct in all 3 representations, simply we are going with the signed magnitude, sign plus magnitude. I want to get plus 87. MSB is 0, 87 magnitude. Then 0, magnitude is 101, 0, 111. It is 87. Yes, it is plus 87 in signed magnitude, in 1's complement, in 2's complement representation. I want to get opposite sign number in 1's complement means take 1's complement of this. If I want to get opposite sign number in 2's complement representation, take 2's complement of this. Right? Is that clear? Let me give one more question. Same, find signed magnitude, 1's complement and 2's complement representation of minus 23 decimal using 8 bits. Minus 23 decimal using 8 bits. Find signed magnitude, 1's complement and 2's complement representations of minus 23 decimal using 8 bits. You need to find signed magnitude, 1's complement and 2's complement representations. First, let us go with the signed magnitude. What is signed magnitude? Sign plus magnitude. What is sign here? Minus. MSB should be 1. What is the magnitude? 23. Converting to binary. What is it here? 2 1s are, 2 1s are, remainder is 1. 2 5s are, remainder is 1. 2 2s are, remainder is 1. 2 1s are, remainder is 0. What is magnitude? 1 0 1 1 1. That means only 5 bits is sufficient to represent this magnitude. But how many bits I need to use for magnitude? 7 bits because it is 8-bit representation. In 8-bit representation, MSB for sign and all the remaining 7 bits for magnitude. So I need to represent this 23 using 7 bits. How can I make that? Appending zeros. Magnitude, I want to make it 23. Right? So here it is 5 bits is sufficient 10111, but I have to use 7 bits. That is the reason I am making it as 0010111. So 10111 is sufficient, but I have to use 7 bits because it is mentioned 8 bits. Be clear about this. Getting magnitude is fine, but depending on number of bits they have mentioned, you need to represent correctly. Yes, MSB is one negative. Remaining 7 bits must be used for magnitude, but in reality, it requires only 5 bits. To make it 7 bits, I'm appending zeros here. Yes, it is now minus 23. In which representation? In signed magnitude representation. In signed magnitude representation. Signed magnitude representation. Sign plus magnitude. Now, I want to get a minus 23 in 1's complement and 2's complement representation. For that, what should I do? First, represent plus 23. Plus 23 using 8 bits. Plus means MSB is 0. 23 is what? 0, 0, 1, 0, 1, 1, 1. What is this now? Plus 23 in all 3 representations. It is plus 23 in all 3 representations. Any doubt in that? MSB is 0, magnitude is 23. MSB 0 positive, right? It is 23 plus 23. In which representation? In all 3 representations. Now, I want to get a minus 23 in 1's complement representation. Then what should I do? Take 1's complement of this. What we get? 1, 1, 1, 0, 1, 0, 0, 0. What is this now? Minus 23 in 1's complement representation. 1's complement representation. Now, I want to get 2's complement representation also. How to get 2's complement representation? Let us see. Take 2's complement of this. It is plus 23 in 2's complement representation also. I want to get minus 23 in 2's complement representation. How can I get? Here it is 1, 0, 0, 1, 0, 1, 1, 1. I hope everyone is able to write 2's complement directly. It is now minus 23 in 2's complement representation. Yes, it is a minus 23 in 2's complement representation. Right. Now, another one. Minus 127 decimal using 8 bits. Find signed magnitude 1's complement and 2's complement representations of minus 127 decimal using 8 bits. Find signed magnitude 1's complement and 2's complement representations. Find signed magnitude, ones complement and twos complement representations of minus 127 decimal using 8 bits. What should I get here? Minus 127 decimal using 8 bits. Now, sign to magnitude. Then what is it here? Sign plus magnitude. What is sign here? Minus. MSB should be 1. What is 127 magnitude? Right? 2 6 2 3 remainder is 1. And again 2 3 2 1 remainder is 1. 2 1 5 remainder is 1. 2 7 remainder is 1. 2 3 remainder is 1. 2 1 remainder is 1. What we get here? It is 7 ones. It is 7 ones. Then what is it here? It is now minus 127. Minus 127 in signed magnitude. Signed magnitude representation. It is minus 127 in signed magnitude representation. Now, let us get ones complement and twos complement representations of minus 127. For that, let me represent plus 127. Plus 0. 127, 7 ones. What is this? Plus 127 in all three representations. In all three representations, it is a plus 127. I want to get a minus 127 in ones complement representation. For that, let me take ones complement of this. Then what we get here? 1 0 0 0, right? 0 0 0 0. It is a minus 127 in ones complement representation. Right? I want to get a twos complement representation of minus 127. Then what should I do? Take twos complement of this. How to get this one as it is, remaining which must be complemented. 0 0 0 0 0 0 1. It is a minus 127 in twos complement representation. Minus 127 in twos complement representation. Right. Some people have been asking about why can't you extend with 1? Where you can extend with 1, I'll discuss. Hold on, don't be in hurry. I'll give you the clarity. Where can you append 1? Let me explain that. So, it is a minus 127 in ones complement as well as twos complement representations. Minus 127 in ones complement and twos complement representations. Right? Now, let me take one more example. Minus 14 decimal using minimum number of bits using 8 bits. Be clear about this. Minus 14 representation using minimum number of bits and 8 bits. Once again, minus 14 decimal representation in signed magnitude, ones complement and twos complement representation using minimum number of bits and 8 bits. Right? Two possibilities are two questions we are doing here. First, start with the minimum number of bits, then we go with the 8 bits. First, let me complete that. So, how many bits required to represent minus 14 in signed magnitude, ones complement and twos complement representation? How many minimum number of bits required to represent minus 14? For that simple thing, what is it here? MSB is 1 because number is negative. I'm going with the signed magnitude representation. So MSB is 1 because sign is a negative. What is the magnitude? 14. 2 sevens are, remainder is 0. 2 threes are, remainder is 1. 2 ones are, remainder is 1. Then what is it here? 1, 1, 1, 0 is magnitude. So MSB is 1. Magnitude is what? 1, 1, 1, 0. What is this, sir? Minus 14 in signed magnitude. Any doubt in that? It is minus 14 in signed magnitude representation. Is that clear? Yes. Minus and 1110 is magnitude. Yes. Now I want to represent the same using 8 bits. Then what should I do? I want to represent the same minus 14 in signed magnitude representation using 8 bits. Then what should I do? Number is negative only, but number of bits is changing. In such cases, what should I do? MSB is 1. Yes, correct. Because number should be negative. Yes, MSB is 1. What is the magnitude? 14. How many bits I need to use for magnitude? 7 bits. When I use 7 bits, actually requires only 4 bits for magnitude, but I need to represent the same magnitude with 7 bits. Then what should I do? Are we appending ones? No. Signed magnitude representation. Sign magnitude. What is it here? Sign magnitude. This is minus 14 in signed magnitude. No doubt in that. I hope. Are we appending ones here? No, we are appending zeros. Because magnitude need not to be represented using 7 bits. Magnitude did not require 7 bits. Then what should I do? Magnitude and appending zeros, because magnitude should not be changing. In this case, we cannot append with 1. Be clear about this. Don't remember blindly. We can extend with 1. Which representations is that? That is also important. In which representation I mentioned, that is also we need to learn. So what is it here? Minus 14. Yes, minus 14. 14 is what? Using 7 bits, I need to represent magnitude 14. That is 0, 0, 0, 1, 1, 1, 0. Actually, 1, 1, 1, 0 is sufficient for magnitude. But according to the specification, I need to use 7 bits. I need to represent 14 magnitude using 7 bits. That's what I've done. MSB is 1 negative, remaining bits for magnitude. Right. So are we appending ones? No. We are appending zeros here. Now, let me go to ones complement representation using minimum number of bits. So if you are calculating the range with 4 bits, right? What is the ones complement representation range? Minus 7 to plus 7. Using 5 bits, what is the range? Minus 15 to plus 15. That means 5 bits is sufficient to represent minus 14 in ones complement representation. Be clear about this. What is it here? Using 4 bits, the range is minus 7 to plus 7 in ones complement representation. Using 5 bits, minus 15 to plus 15. Yes, using 5 bits, it is possible to represent minus 14. Right? Minus 14 is falling in the range of 5 bits. It is first time, that is minimum. Right? Be clear about this. What is it here? 5 bits is sufficient. That is minimum number of bits to represent minus 14 in ones complement representation. Then what should I do? Let us go with the ones complement rules. MSB should be 1. What is the weight of MSB? Minus 15. Any doubt in that? Any doubt in that? Minus of 2 power n minus 1 minus 1. According to the rules we have discussed, MSB weight is what? Minus of 2 power n minus 1 minus 1. When I am using 5 bits, substitute that. Minus of 2 power 5 minus 1, it is 4 to power 4 minus 1. That is 2 power 4 is 16. 16 minus 1 is 15. So MSB weight is what? Minus 15. And what must be the decimal equivalent? Minus 14. Then what should I add? Plus 1. Where is the plus 1 weight? Last bit. So these 3 bits are zeros, then it is 1. Check it. Weight of MSB is how much? Minus 15. What is the decimal equivalent we are expecting? Minus 14. What must be added? Plus 1. Where is plus 1 weight? LSB. Right? What is this now? Minus 14 in 1's complement representation. Using 5 bits. That is minimum number of bits we have used. Be clear about weights. When you know the weights, when you know the range, then only we can proceed here. Right? Now, I want to get minus 14 in 1's complement representation using 8 bits. Point should be understood correctly. I want to get minus 14 in 1's complement representation using 8 bits. Then originally what 10001 is minus 14, but I want to use 8 bits. Then extending with MSB. Yes, it is what? Minus 14 in 1's complement representation. Here I can do extension with the MSB1. Yes, 10001. This is minus 14 using minimum number of bits. How do you confirm this? 5 bits is sufficient because we know the range of 5 bits in 1's complement. It is minus 15 to plus 15. So minimum number of bits required is 5. With 5 bits if you are proceeding, MSB should be 1. Why? Number is negative. What is the weight of MSB? Minus 15. How am I calculating that? Minus of 2 power n minus 1. Minus 1 is the weight. Yes. Minus 15. And what must be the decimal equivalent of this representation? Minus 14. Then what should I add for this? Plus 1. Where is plus 1 weight? Last 2 bit LSB. 0, 0, 0, 1. Yes, minus 15 plus 1 it is minus 14. In 1's complement representation using minimum number of bits. But whenever it is required to represent using more number of bits, here I can extend with MSB. Right. Now, if I ask say minus 14 using 16 bits, then what should I do? Again, writing 8 ones in front will give minus 14 only. Sorry, minus 14 only using any number of bits you can represent by extending MSB, which is sign bit. But in this case, when number of bits required for magnitude is what? Only 4 bits. 1, 1, 1, 0. But I need to represent same magnitude using more number of bits. There, I need to append with zeros only. When you are extending with in only magnitude in signed magnitude representation, sign is separator. And magnitude is what? 0, 0, 0, 1, 1, 1, 0 is again 14. Right. Now, let us try minus 14 in 2's complement representation using minimum number of bits. Once again, let us find 2's complement representation of minus 14 decimal using minimum number of bits. How many minimum number of bits? Using 4 bits, what is the range? Minus 8 to plus 7. Using 5 bits, minus 16 to plus 15. Be clear about this. Using 4 bits, the range is what? Minus 8 to plus 7. Using 5 bits, minus 16 to plus 15. So, minimum number of bits required to represent minus 14 in 2's complement representation also, it is 5. Right? So, as number is negative, MSB should be 1. Can you say what is the weight of MSB using 5 bits in 2's complement representation? Minus 2 power n minus 1 minus 2 power 5 minus 1. 5 minus 1 is 4. Minus 2 power 4. It is a minus 16. It is a minus 16. What should be the decimal equivalent? Minus 14. What must be added to minus 16? Plus 2. Where is plus 2 weight? 0, 0, 1, 0. It is minus 14 in 2's complement representation. 2's complement representation. Check it correctly. Minus 16 plus 2. It is minus 14. It is minus 14 in 2's complement representation. I want to get a minus 14 in 2's complement representation using 8 bits. Then what should I do? Originally what? 10010 is minus 14 using minimum number of bits. But I want to extend the bits. Then what should I do? Appending with the ones. So now it is a minus 14 in 2's complement representation. Here we can extend with the 1 in 1's complement and 2's complement. But in the magnitude, whenever it is required to extend the bits, how can I add ones? If I add ones here, it will be changing. The value will be changing. Check it correctly. The same question let us do with the previous method, what we have done. So let us use the same, right? Minus 14 decimal using 8 bits. Directly we do that. What is it here? Sign to magnitude, 1's complement and 2's complement. So what is magnitude? 14, 2, 7's are, remainder is 0, 2, 2's are, so 2, 3's are, remainder is 1, 2, 1's are, remainder is 1. What is it here? 1110. So 1110 is magnitude, but I need to use magnitude with 7 bits, then appending zeros. What is this here? 14. It is 14. I want to get minus 14, then MSB is 1. As it is 8 bits, excluding MSB, what is that here? 7 bits I need to use for magnitude. Magnitude requires only 4 bits, but I have to represent magnitude with 7 bits. Then in the magnitude, I'm appending zeros. Then it is a sign. What is here? MSB is sign plus magnitude. Sign is MSB, remaining bits for magnitude. Yes, sir. MSB is 1. Why? Sign is negative. It is a minus 14 in signed magnitude. I want to get a minus 14 in 1's complement and 2's complement representations using 8 bits. First, let me write plus 14 using 8 bits. What is here? Plus 0. Magnitude is what? 0, 0, 0, 1, 1, 1, 0. It is a plus 14 in all 3 representations. Any doubt in that? It is plus 14 in signed magnitude, plus 14 in 1's complement, plus 14 in 2's complement representation. Let me get minus 14 in 1's complement representation. How can I get that? 1's complement representation. So taking 1's complement, 1, 1, 1, 1, 0, 0, 0, 1. What is this now? Minus 14 in 1's complement representation. I want to get minus 14 in 2's complement representation also. Then what should I do? Take 2's complement of this. What we get here? 0 as it is, 1 as it is, remaining bit should be complemented. 0, 0, 1, 1, 1, 1. What is this? Minus 14 in 2's complement representation. Minus 14 in 2's complement representation. Check with previous. This and this must be checked with these two. Yes. Observe, previously we have done with extending sign bit. By representing using minimum number of bits, extending sign bit. By representing using minimum number of bits, extending sign bit. Instead of this, what we have done? Directly representing positive number using 8 bits and taking 1's complement of that, taking 2's complement of that. Shweta, already we discussed yesterday, when we are able to represent positive number, if you are taking complements, we are getting negative number in that representation. If I'm taking one's complement of that, we are getting negative number in one's complement represent. If I'm taking two's complement of that positive number, I'm getting negative same minus 14 in two's complement representation. That is the reason we are representing plus 14, then taking complements. Then taking complements. Shweta Sharma. Thank you. Before going to next question, if anyone is having any doubts with respect to these, I would like to answer those questions. You can raise the hands because here some people may be having their own interpretations, their own confusions. Let me clear those doubts here. Right, instead of waiting for completion of session, right, let me ask your doubts. Ankur Kashyap. Ankur Kashyap. Are you there? Yuga Sri.
Good afternoon, sir.
Yeah, good afternoon.
Sir, in this minus 14, 1110 is there, sir. And before that, you
Minus 14, it is not 1110. 1110 is magnitude, it is 14.
14. Yes, sir. Minus is the indicated the 1. Between
Yes,
that,
MSB is 1 to say it is negative.
Yes. You wrote 3 zeros, no, sir.
Yes.
Why it is, and if any number also like
See,
that.
question is minus 14 using 8 bits.
Yes, sir.
I have to use 8 bits. See, listen. 8 bits I need to use. It is sign plus magnitude. In sign plus magnitude, what I mentioned, MSB is sign, remaining n minus 1 bits for magnitude. When I'm using 8 bits, MSB is for sign, remaining 7 bits for magnitude. Right? But magnitude doesn't need 8 bits. Sorry, 7 bits. It is not required. Then what should I do? Can I neglect the bits? No. I need to make this value 14 with true binary weights. For that, I need to append zeros only. Right?
Before that, 4
instead of 0, what is the other possibility? 1. Try with 1. What happens? We get some other magnitude with 7 bits.
Sir, for minus 15 and minus 16, this is some different, I think, sir.
I'll extend that. Please, if you have any doubts in my questions, please let me know. I'll give you that clarity in the next. Whatever is required, I do. But what is the doubts you have in my questions for what I've discussed? Please let me know. Is it clear now?
So for minus 15, in middle of that zeros you had, no, sir, ones and zeros.
Minus 15.
In 4F page.
4F page. Okay. Select. Okay. 4F page. Yes.
So minus 15, we calculate that is, we got 1, 1, 1, 4.
Why we are getting minus 15 here?
4 ones we get, no, sir, for LCM.
No. That is not the way we have discussed. Weight of MSB in one's complement representation minus of 2 power n minus 1 minus 1. MSB weight. Do you remember yesterday?
Yes, sir.
Right. So if I'm substituting 5 in n minus of 2 power 5 minus 1 minus 1, what we get? Minus of 2 power 5 minus 1, 2 power 4 is 16. 16 minus 1 is 15. What is weight of MSB? Minus 15. What must be decimal equivalent? Minus 14. Minus 15 is weighted value. What should be added to this? Plus 1. Where is plus 1 weight? LSB only. So, see here. It is a minus 15. It is a plus 8, plus 4, plus 2, plus 1. We know the weights, right?
Yes, sir.
Now, minus 15 plus 1 can give minus 14. That is the reason, whichever the weights we need to add, there only we are making ones. Minus 15 confirm, because number is negative means MSB should be 1. MSB is 1 using 5 bits. MSB weight is minus 15. But decimal equivalent expected is what? Minus 14. That means minus 15 plus 1 should be added. So, plus 1 weight is there for LSB only. And coming to 2's complement representation, weight of MSB is what? Minus 2 power n minus 1. Minus 2 power 5 minus 1. Minus 2 power 4, it is minus 16. And if you are observing weights, minus 16 plus 8 plus 4 plus 2 plus 1. That is the reason minus 16 plus 2 becomes minus 14. That is the reason I have mentioned here once in these two positions. And after that, if you are requiring 8 bits, extending with MSB, because it is already minus 14. It is not plus 14, it is already minus 14. Then I want to get minus 14 using more number of bits in 1's complement and 2's complement by extending the bits. Understood? Yugashri?
Sir, for 1 is the negative sign is there, na sir. Then 3 is then 2 you wrote once, na sir. The magnitude
Here
and the sign, na
or
sir.
here or here. Be specific, because where you are talking, I don't know. Your mind is there on screen. Something it is
No, sir, in the 16 you
but I need to catch that. Which one? This one?
16 in 16 minus 16 you wrote
Yeah,
the magnitude.
Why are you saying
100.
again magnitude? Why are you saying again magnitude? Is it sign magnitude?
100.
You are talking 1's complement representation. Why are you talking again magnitude? If it is signed magnitude only, we need to talk about sign plus magnitude. If it is 1's complement, you go with the weights. Otherwise, blindly follow that taking complements. Yugashri.
Okay, sir.
Right? So, if I say signed magnitude, you need to talk about magnitude. When I'm saying 1's complement representation, why are you talking again? MSB is 1 again magnitude. Is it signed magnitude representation? No. Rules are different from signed magnitude. Why you are still in signed magnitude only? Come out of signed magnitude. Please understand the concepts correctly. I have discussed each and every point. So that's what I've said. Don't assume. Don't create a boundary. Right? See, signed magnitude, what we said? Signed magnitude. There you apply that. But why are you applying this? Again, in this also, MSB is 1 sign, next is magnitude. Did I say that like that? No. Yesterday also I discussed these points. Go with the weights for representing. So MSB weight is negative, remaining bits weights are positive. But which are should be added to get expected? Yes, MSB should be 1. Why? Number is negative. Because in all 3 representations, common rule is MSB 1 negative, MSB 0 positive. And as it is negative number, MSB should be 1. I'm using how many bits? 5 bits. When I'm using 5 bits, what is the weight of MSB? Minus 15. What is next bits? Plus 8, plus 4, plus 2, plus 1. So wherever minus 15 is there, we are making 1. And result must be minus 14. What should be added? Plus 1. So minus 15 plus 1 is minus 14. That's what I've done. In this next one, 2's complement, yes, MSB is 1. MSB weight is how much? Minus 16. Right? Now, what should be added? Plus 2 should be added. So minus 16 plus 8 plus 4 plus 2 plus 1 weights in order. Then what should I add? Minus 16 plus 2. It becomes a minus 14. Right? Yugashri.
Okay, sir.
Please spend time, effective time. You will understand 100%. There won't be any doubts. Right?
Yes,
Spend effective time on my discussion last class. Please go through each and every point I discussed. Will be uploaded slides, sir. So,
Okay, sir. Thank you, sir.
right. Anyone else have doubts? Dinesh Roy, your wish, whichever is comfortable to you. Sai, Banawat Sai, please try on your own. Right? Okay. Someone raising hands. Let me answer those doubts. Right. Yugasri, can I disable now yours? Sai Pratyush. Do you have any doubts? Sai Pratyush.
Hello?
Yes. Yes, sir.
Sir, it is the same as the thing we did yesterday while justifying the name, right?
Be
But it-
clear. Be slow. Because in transmission, it may be having some noise. So be little bit slow.
Yesterday we did the concept called justifying the name, how we got one's complement and two's complement,
Yes.
right?
Yes. That's what we are using here.
Here we are doing just the opposite of that, right?
No, no, no. We are representing positive number, taking complement of that to get negative number.
There while justifying, we have already the negative number, we are taking it
If
to
it is
before-
already negative number, if you want to get positive number, take 2's complement of that.
Okay. Okay, sir.
Because it
Thank
is
you.
easy to represent positive number, we are going with that. What is it here? 0 MSB magnitude we are representing. That is positive number. I want to get negative number. Then take
Yes,
1's
sir.
complement and 2's complement.
Okay. Okay, sir.
Right.
Thank you.
Thank you. Thank you. Sagarika. Sagarika. Any doubt?
Hello.
Yes.
Sir, if when they ask it for representing minimum number of bit, if directly we get 1 in MSB, then no need of adding 1 again for representing a negative number, sir.
That depends on what number you want to represent.
Okay.
That depends on what number you are representing. So MSB is 1 is indicating number is negative. That is for all. But MSB is not only for sign in 1's complement and 2's complement. MSB is having a weight. With that weight, we need to proceed to complete that representation.
Okay.
So what is MSB weight we are calculating? Then what is the number we want to represent? Then what should be added to that MSB weight?
Okay. If at all that if including magnitude we are getting the same number, then we have to add 1, sir. Then we shouldn't add actually.
If MSB itself is sufficient, then no need to add remaining ones.
Okay, sir. Okay, okay. That's it.
Naveen,
Good afternoon, sir.
yeah, good afternoon. Tell me.
Correct me if I'm wrong. I have just repeating myself about the concept I understood. When the magnitude is given, in order to get the signed representation, we just according to the negative, we take 1
Right.
or 0 before
Yes,
the
that's
actual
it.
number,
Right.
and then we conduct the factorization of the given number, and we, as usual, right, sir? So in order to get
I did not understand. First thing I understood. Magnitude, if I know magnitude, appending 0 for positive, appending 1 for negative is
Yes.
completing
Yes,
signed
sir.
magnitude.
After completing the factorization, sir, 14 to.
Factorization. Please don't use the words, sir.
I'm sorry, sir. I'm sorry.
What is
So
the
we have-
factorization? I don't know. Right. Yeah.
So we got 1111110. That's the binary representation of 14, right, sir? So by placing
Please. Yeah. Naveen. Don't be in hurry. I'm
So we
there to
got-
help you. I'm there to help you.
Okay.
I'll take as much time as possible. Let us
Yes.
learn concepts correctly. Right?
So we got to sign the magnitude representation of -14, right, sir?
Sine
So-
to magnitude representation of -14 means
14?
yes. What we have done,
We
right?
according to
This
it,
is
since the sign is
1110 is the magnitude,
yes, sir.
but I cannot append once again continuously
Yes, sir. So we have added one.
because sign extension is not applicable in sign to magnitude representation,
Okay.
right? It is applicable only in one's complement and two's complement representation.
Okay. So
I
you
haven't
know,
talked about right sign extension is sign to magnitude. Don't assume.
so why have we written in we have written in the answer one before the mind representation? We have written one, sir. So be according to sign, right?
Yeah, this is sign.
Yes, sir. So we have represented. So
In this,
okay.
this is sign. In this is sign. In this is magnitude sufficient.
Yes.
In this is
Yes, sir.
magnitude.
Okay.
Will there be any problem? No.
So we do not have any problems, sir. But according to this, I have understood it is a technique rather than a concept, sir. I have memorized it, the entire entire process, so that I can apply to any other problem that I'm given, right, sir?
Yes, you can.
So I have memorized it as a technique rather than a concept. Is it okay?
You wish.
That is the that is a
Your wish.
okay. That is an
But,
ethical dilemma, sir.
But
Actually.
don't assume some things on your own.
Okay.
I'm not responsible then.
So that is why I'm asking about for because in coming classes,
No.
actually, sir, I have it. I
See,
have
one thing.
Okay, okay.
What you are saying, what is in your mind may not be same.
Yes, sir.
If I say yes, follow this 100%, then you may be having your own assumptions in your mind that
Yes,
you did not express. Then concept becomes wrong.
yes, sir.
One thing, either follow me or
Okay.
go with your own assumptions.
No, sir, I'm not assuming anything, but I rather ask you to confirm it.
Yes, yes,
So you said it right. So
Yes.
I'm happy, sir.
right.
Okay, thank you.
I think I answered already Sagarika. Is it? Sagarika, do you have any doubt?
No, sir.
Already discussed, right? Please lower the hands when you have. Pratyush. Pratyush, do you have doubt? Pratyush, do you have doubt?
Yes, no, sir, no doubt. I'm just saying rather than using that formula like minus of 2 to the power n minus 1 minus 1,
Okay.
we can directly write positive number and then we can
take compliments.
convert.
Then take compliments. Then take
Yeah.
compliments.
That's easier.
Yeah.
Yeah, that will be easier. That's the only thing that I had to say. Okay, thank you, sir.
I'll remember your name. I'll be calling your name soon in the next slide.
Okay, sir. Okay, sir.
Why? You will understand then, right? Wait. Pratyush Kumar. I'll
Okay, sir.
remember your name,
Okay.
right? Anyone else? Okay. Then everyone is clear with the concepts. Right. Right. Find 2's complement representation of minus 128 decimal using 8 bits. Neha, there might be some reason when I'm taking doubts in between. When you don't have doubt, please wait. Right. Right. Very good. Very good. Very good. Good answers I'm observing. Right. Right. Minus 128 should be represented using 8 bits in 2's complement representation. How many bits I need to use? 8 bits. How many bits I need to use? 8 bits. Yes, 8 bits. MSB is 1. Why are you saying that MSB is 1? Number is negative. Number is negative. Weight of MSB is what? Minus 2 power n minus 1. Minus 2 power 8 minus 1. Minus 2 power 7. 2 power 7 is what? 128. Any doubt in that? MSB weight is how much? Minus 128. What is the weighted value of MSB? 1 into minus 128 is minus 128. What must be the decimal equivalent? Minus 128. What must be the remaining bits? Zeros, because nothing is required to add. It is minus 128 in 2's complement representation using 8 bits. Using 8 bits. Confirm that. But if you are using the methods which we have used till now, then you may be running into a problem. What is that? 128. If I calculate 128 magnitude, 264, the remainder is 0. Then 232, remainder is 0. 216, the remainder is 0. 28, the remainder is 0. 24, the remainder is 0. 22, the remainder is 0. 21, the remainder is 0. What is here? Magnitude is 1, 0, 0, 0, 0, 0, 0. It is 128. If I want to represent plus 128, then taking 2's complement, I need to append a 0, then take 2's complement. But here it is saying that it requires 9 bits. Then you will be getting a doubt. Plus 128 is not possible using 8 bits. Then minus 128 also not possible. Is a wrong perception. The range of 8 bits is minus 128 to plus 127. Using 8 bits. The most positive number is plus 127, but the most negative number is minus 128. Plus 128 is not possible using 8 bits. Minus 128 is possible using 8 bits. Right? Here you can understand the importance of weights and all. So far we have discussed. Instead of just taking complements, people might have understood it is easy just taking complements. No. Go with the weights. Whenever such questions are given, then obviously you will be into trouble. Right? So you should go with weights also. In this case, I cannot use complements method Because plus 128 cannot be represented using 8 bits, but minus 128 is possible. Then where is the possibility of using complements method? It is not overflow. Many of you have mentioned there is an overflow. It is not overflow. It is not overflow. It can be represented using 8 bits. Yes, that is Pratyush. I think about you only, right? I want to talk, right? So just now I mentioned what happened, Nagalingeshwar Rao? Any problem? Check it, Pawan Kumar. Yes, in signed magnitude and one's complement, right? It is not possible because in signed magnitude minus 127 to plus 127. In one's complement minus 127 to plus 127. In two's complement it is minus 128 to plus 127. Plus 128 is not possible using 8 bits, but minus 128 is possible. How can I confirm that? Using weights, right? Nagalingeshwar Rao, to say it is plus 128, 128 is 7 zeros already 8 bits, appending again 0, then it becomes plus 128. 128 is 17 zeros, magnitude only 170, there is 8 bits required for magnitude. To say it is plus 128, you need to append a 0, then it becomes 9 bits. Plus 128 cannot be represented using 8 bits. I am confirming. Go with the range, you can calculate. Using 8 bits, the range is minus 128 to plus 127. Plus 128 is not possible. Yes, Ashok Kumara. Right. It cannot be represented. Overflow. Annapurni, wait. Nagalingeshwar, thank you for understanding. Very good. Yes, that's what I expect. You may be having your own assumptions. You should come out of that assumptions. Don't make it easy. If I'm making it easy, means I'm not covering in depth. If you are comfortable, if you are feeling it is easy, means I'm not covering in depth. Every concept has its own levels. Right? There must be guts to cover that in depth also. I can make it easy instead of covering this example. I can say that just take complement. It is easy. Pratyush Kumar was asking, yes, I'm comfortable with that. I'm using that only. Then I said, wait, next slide, I'm going to ask you, right? Now you might have understood why I mentioned those words, right? So in-depth is important. Just taking complements is easy. No. What is the rules of each and every representation? And what is the weights of each and every representation in each and every bit? Right? What is exactly concept? Then you can understand all this. No need to depend on shortcuts. Shortcuts may be failing. Concepts never fail. That's what my slogan always. Concepts never fail. Shortcuts will be failing. Yeah, now. Right. That you can understand, Gopal Krishna Reddy. Yes, that is correct. After taking 2's complement, if you are observing there is sign extension, then extending that extra bit, neglecting that. Right? That's that. Gopal Krishna. Yes. Thank you, Ashutosh. Right. Still. Right. Now, find signed magnitude, 1's complement and 2's complement representations of plus 23 decimal using 8 bits. Yes. Right. Simple thing. What is it here? 23. Let me get magnitude. 2 1's are, remainder is 1. 2 5's are, remainder is 1. 2 2's are, remainder is 1. 2 1's are, remainder is 0. Then what is it here? 1 0 1 1 1. But I need to use 7 bits for magnitude, means I need to append 2 zeros. What is this now? 23 magnitude. But I want to make it plus 23. Then appending a 0. What is this now? See, it is plus. It is 23. So it is plus 23 in which representation? In representation, signed magnitude. Correct? Not only signed magnitude, it is also in 1's complement and also 2's complement representation. Why? I don't need to take complement because I am representing plus 23. If I want to get minus 23, I have to take complement. But expected is what? Plus 23 only. Then 0 0 0 1 0 1 1 1 is plus 23 in 1's complement and 2's complement representation also. 2's complement representation also. Right? Because it is positive number. This point also we have discussed. What is that? Positive numbers representation is same in signed magnitude, 1's complement and also 2's complement representation. Is anyone having any doubt still? No? Every point is important which I have discussed. Don't take it easy. Every point. Right? Correct. Very good. Now you are in right way of understanding signed number representations. Don't depend only on complements. You should understand concepts also. Then we will be confident for any question. I would like to ask a question now at this stage because I have to. The same concept I can complete in 20 minutes. It took almost 2.5 or 3 hours. This concept still I've been discussing. I can teach in a simple way. I can teach the way I'm doing now. Instead of discussing this much, I can make it simple. In that simple, every question looks like very simple. And every concept looks like very simple. You will not find any difficulty. And if you are finding difficulty in understanding the way I'm discussing, then I can switch over to simple thing. That I can do. What way you want to learn this subject from me? I would like to know. Wait, Arun, Revant, wait. Right. Many are saying that, not many, all of you are saying that want to learn the subject in depth. Thank you for your interest. Because when you are getting around 10% of weightage for the subject in most of the competitive exams, which is going to decide because where there is a possibility for doing mistake. And I would like to say few things about the subject because we'll be getting into next some more concepts. Before getting into that, I would like to give you some more observations, my observations. Some subjects which we learn, there may be some method, there may be some procedure, depending on possibilities. And most of the questions fall under those conditions only. For each and every condition, there will be a procedure. We are remembering that procedure instead of concept. That we are proceeding. It will be comfortable. Not all the subjects, right? Here, logical questions, wherever that your assumptions and formulas and statements are failing, there they are framing the questions. Especially nowadays, they have been framing questions where our assumptions are failing. Don't worry, Joseph. I won't do that. I never do. Nagalingeshwara, no need to worry about that. I'll take care of that. Right. Thank you, Francis, sir. I do my level best to reach your expectations, sir. Right. Okay. Finally, I understood many are interested in subject because if there are, for example, 5 questions or 6 questions from the subject, 2 questions are very easy. No need of coaching. 2 questions are moderate. With coaching, some procedures, some formulas, some methods, you can answer those 2 questions. There are 2 more questions which they are covering from advanced. So if you are expecting better rank, you need to cross 2nd level. You need to answer some of the questions in 3rd level also. Then only we can be into expected rank. I think everyone is dreaming about top 10 or top 100 or top 500. At the most, top 1000 people may be expecting. At least top 1000 you might be expecting. That's what I think by imagining myself in the class preparing for exam. So there is reason to get into that. Obviously, you have to answer some of the questions in 3rd level also. For that, simple methods may not be sufficient. Remember these words, not only the subject, every subject. So you should have that patience to learn and give a chance to the faculty to explain in depth and have some patience, give your 100% presence, right? Try to capture maximum information from the faculties. As it is not offline, it is online. So there won't be much interaction to meet personally also after the class. So may not be getting such inputs. So please motivate yourself and sure you are going to win this race with this ACE coaching, right? So Manisha, I'll give you time at the end. Please wait. Right. Now. Next is subtraction using complements, which we know already. Let us revise that concept. Let me take A is a number in radix R minus B is a number in radix R. I want to get a difference also in radix R. Radix R. So A is a number in radix R, B is a number in radix R, A minus B difference also I want to get in radix R. Right? A minus B operation we are performing. For this, assume that already adder circuit is implemented. Already adder circuit is implemented. Instead of designing an again subtractor circuit, using addition methods, we can complete the subtraction also. What are those methods? Let us see. It can reduce the complexity of ALU because adder can be used for subtraction also. With these methods, adder also can be used for subtraction. Instead of implementing subtractor circuit separately, already implemented adder circuit can be used for subtraction with some additional steps. So additional circuitry is not required to implement. What is it we are doing here? By using adder circuit, how can we perform subtraction? See here, A is a number in radix R, B is a number in radix R, A minus B difference you want to get in radix R. Right? Then For this, we have two methods. What is it here? R's complement method. Second one is a R minus 1's complement method. Right? R's complement method, R minus 1's complement method. We have two methods for the subtraction. So A is a number in radix R, B is a number in radix R, A minus B difference we want to get in radix R. Right. So let us see what is the methods we are using one by one. First one is a R's complement method. R's complement method. In that first step is what we are doing here, A plus R's complement of B. What we are doing here, we are adding. For that, what we are doing, first take R's complement of B, add to the A. Second one is observe the result. In that observation, first observation is what? A greater than B. If A is greater than B, there will be final carry out is 1. If A is greater than B, final carry out means carry from MSB, carry from MSD will be 1. Then the result is positive and discard carry. Sum is a result or difference. What is it here? If A is greater than B, final carry out will be 1. Or when final carry out is 1, the result is positive, then discard that carry, sum is the desired result or expected result. Second condition is if A is less than B, final carry out 0. I'm not saying that all the carries are zeros. What I'm saying here, carry from MSB or carry from most significant digit will be 0. Then what happens? The result is negative. How to get that? Take R's complement of result and produce negative sign in front. What we're doing here? When A is greater than B, discarding carry, sum is the result. That is whatever the result we are getting, that is a difference. Whatever sum we are getting, that is the result. If A is less than B, the result is negative. How to get result or difference? Take R's complement of sum. R's complement of sum. I can say here it is sum also. R's complement of sum. The sum we are getting because this is sum. A plus R's complement of B. In that, if final carry is there, result is positive. If final carry is not there, result is negative. So if result is positive, whatever is there in sum, that is the difference. If final carry is not there, that means the final carry is 0, then result is negative. To get actual result, take R's complement of sum and use negative sign in front. That is R's complement method. First method is what? R's complement method. In that, what we are using? A minus B. Right? So for that, A plus R's complement of B we are doing. A plus R's complement of B we are doing. In that, two possibilities. Final carry may be there, may not be there. If final carry is there, result is positive. Right? How to get result? Excluding that carry, remaining digits of sum will be the result. That is difference. If A is less than B, final carry will not be there. Final carry will not be 1, final carry will be 0. Then taking R's complement of sum, producing negative sign in front is giving the result. Right? And second one is R minus 1's complement. Again, here also what we are doing? A plus R minus 1's complement of B. Again, second step is what? Observe the result. In that first one, once again, A greater than B. Final carry out will be 1. The result is a positive. And add carry to least significant digit of sum. Add carry to least significant digit of sum. Carry will be added to the last bit. Carry around. Second one. If A is less than B, carry out is not 1. Carry out will be 0. Then the result is a negative. Comma. Take R minus 1's complement of sum and use a negative sign in front. Use negative sign in front. Same. When carry is not produced, final carry is not 1, final carry is 0, then what we need to do? Take complements. If it is R's complement method, take R's complement. If it is R minus 1's complement, take R minus 1's complement. But when carry is there, in both the cases, result is positive. But in R's complement method, we are not using that carry, we are discarding that carry. But in R minus 1's complement method, adding that carry to LSD of sum. To get result, adding carry to LSD of sum. Once again, two methods very clearly. In two methods, respective complements of B will be added to A. When we are performing A minus B, so A plus complement of B. So in R's complement method, R's complement of B. In R minus 1's complement method, R minus 1's complement of B. In two methods, if carry is there, that means final carry is 1, then result is positive. Final carry is 0, result is negative. Right? When result is negative, how to get result? Take respective complements of sum and use negative sign. If it is R's complement method, take R's complement of sum. If it is negative result, final carry out is 0. Final carry out is 0 is confirming result is negative. How to get result is we need to take respective complements and produce negative sign in front. If it is R's complement method, take R's complement of sum, produce negative sign in front. If it is R minus 1's complement method, produce a negative sign after taking R minus 1's complement of sum. But for positive result, in these two cases, carry out is 1, final carry out is 1. But in R's complement method, discarding carry, in R minus 1's complement method, adding 1 to or carry to least significant digit of sum. That is procedure. Right? R's complement method, R minus 1's complement. go through these steps correctly. Follow that. Subtract these unsigned binary numbers using 2's complement and 1's complement method. 2's complement and 1's complement method. Subtract these numbers using 2's complement method and 1's complement method. One information about this topic, they won't ask you to subtract in objective exams. Using 2's complement method or 1's complement method, we don't need to subtract to get the difference. How to get difference? Binary subtraction, we can say what is the result we can say. But how we are getting that result is in different method. 2's complement method or 1's complement method. R's complement method or minus 1's complement method. We are using 2's complement method and 1's complement method for subtraction. To say the difference, I can say directly 10001 is the result because I can subtract directly. But how we are getting questions in objective exams is how we are getting questions in objective exams is based on the procedure. When final carry out is 1, which of the following is correct? When result is positive, which of the following is correct? When result is negative, what are the next steps we need to do in 2's complement method? Then options will be given. Based on the procedure, they have been framing questions. For objective exams, the procedure is important. For conventional exams, all this, whatever we are doing is also important. So, they won't ask you to subtract using 2's complement method and 1's complement method to get difference. But how they are framing questions is based on the procedure. Even though they are asking you to subtract using 2's complement method, I won't use 2's complement method. I can say what is the difference directly. By subtracting directly, we can perform. I don't need to use any 2's complement method or 1's complement method to say the difference. Yes or no? Can we subtract one from another? Yes, we can perform subtraction directly. Yes or no? Clear? Are you here? Right. Yes. Let us see what is the difference. Can you say what is the difference? 1, 1, 0, 0, 1 should be subtracted. What is that here? 1, 0, 0 should be subtracted. Let me do that subtraction. I'm not using 2's complement method or 1's complement method. I'm writing directly difference. What is that? 1, 0, 0, 0, 1. This must be the difference. I know the difference directly. I'm not using 2's complement method. I'm not using 1's complement method. I know the difference. Now, I want to get this difference using 2's complement method and 1's complement method. Let us do that. So first, let me use 2's complement method. For that, what is it here? It is A, it is B. Then what should I use? A plus 2's complement of B. That means A 11001 plus 2's complement of B. What is 2's complement of 1000? 1000 only. Am I right? 2's complement of B, R's complement of B. Then 1, 0, 0, 1 plus 1 is 0, 1 is carry, 1 plus 1 is 0, 1 is carry. Then Challa Asha, please wait. In 2's complement method or R's complement method, what we mentioned, discarding carry, sum is the difference. ये तो different answer है, ये गलत है. Procedure I have used correctly. Answer I know, but I am not getting answer which I know in this. Reason is A and B must have equal number of digits. Then only we get correct result. What happened? Challa Asha. You have been. Challa Asha.
Sir, can you show me 7th and 8th frames once? Like due to technical problem, I couldn't be able to reach through that.
You would have messaged me because you have been rising.
I messaged. No, sir, I messaged you thrice, but I think you didn't.
I did not.
see it.
Sorry. Right, okay.
Thank you, sir.
Right. 7th, 8th, right? You are 7th, 8th, 9th, okay. 10th. 8th, 9th, 10th. Now we are in 11th. Right. Here, what we mentioned, A plus 2's complement of B. Before using procedure, what you must know is A and B must have equal number of digits. In this binary, equal number of bits. Then only we get correct result. So A and B are unsigned numbers. Then what should I do? A is 11001 binary minus 01000 binary. Making equal number of bits can guarantee the result. So here we haven't done that. That is the reason it is giving wrong result. Some of you have written that 00001 is the difference, which is wrong. I know the difference. I need to get this difference using 2's complement and 1's complement method also. What is it here? 11001 plus 2's complement of B now. Now you may understand the importance of zeros in the left for integer part. Right? Can I neglect this 0? No. I need to include that 0 and get complement. Then only we get correct result. 0, 0, 0, 1. Now it is 1. Am I right? Right? 2's complement of B. R's complement of B. A directly plus R's complement of B. A and B are unsigned binary numbers. Before proceeding to use the procedure, I need to make equal number of digits, equal number of bits. That is the reason 11001 is A. B, I have adjusted number of bits to 5. It is 01000. Now A plus 2's complement of B. Right? 0, 0, 0, 1 and complement of 0 is 1. Now let me add 1, 0, 0, 1 plus 1 is 0, 1 is carry, 1 plus 1 plus 1 is 3, 1 is final carry. Now discarding carry, sum is the difference. Yes, that's what I'm expecting. I have to get that correct result. I may be using any method, but difference should not be changing. Result should not be changing. Result must be whatever we are expecting. Yes, I'm getting 10001. That is a 2's complement method. Now 1's complement method. A 11001 plus 1's complement of B 10111. Right? 1 plus 1 is 0, 1 is carry. 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 1 plus 1 plus 1, it is 3, it is 1, there is a final carry. In R minus 1's complement method, what we mentioned? Add carry to least significant digit of sum. Then what we get here? 1, 0, 0, 0, 1. Yes, I'm getting expected. By adding carry to least significant bit of sum, we are getting expected result. Yes, done. Right. So before using procedure, make sure that both A and B are having equal number of digits. Yes, Nagalingeshwar Rao. Yes, it must be. Then only it gives a correct, not sign extension. Manisha, it is not sign extension. Right? Let us use 2's complement method and 1's complement method for this unsigned binary numbers A minus B. Right? First one, 2's complement method. Before that, what should I do? Adjusting number of bits 0, 1, 0, 0, 1 binary minus 1, 0, 0, 1, 0 binary. Making equal number of bits. Then 2's complement method A 0, 1, 0, 0, 1 plus 2's complement of B. 2's complement of B. What is that here? 0, 1, and 1, 1, 0. Let me say here 1, 1, 1. 1 plus 1 is 0, 1 is carry. 1 plus 0 plus 0 is 1. Then what is that here? It is not giving final carry. There is no carry out of MSB. Then the result is negative. Then what should I do? Take R's complement of sum. Take 2's complement of sum and produce negative sign in front. So once again, what is it here? From this addition, what you are observing? There is no final carry. That is confirming result is negative. How to get result? Take R's complement of sum, because I'm using R's complement method, which is 2's complement method. Take R's complement of sum and produce negative sign in front. What do you get here? 1, 0, 0, 1, 0. That is a negative sign. To consider result, this is what we need to. This is magnitude, this is negative sign. How to get result? Take R's complement of sum and produce negative sign in front. Now, ones complement method. What is it here? 0, 1, 0, 0, 1 plus 1's complement of B 0, 1, 1, 0, 1. Then let me add 1 plus 1 is 0, 1 is carry. 1 plus 0 plus 0, it is 1. 0 plus 1 is 1. 1 plus 1 is 0, 1 is carry. 1 plus 0 plus 0, it is 1. Is there final carry? No, it is not having final carry. Then what should I do? Take 1's complement of sum and produce negative sign in front. So 0, 1, 0, 0, 1 and producing negative sign in front. Yes, both are giving same result. But yes, if you are providing sufficient number of bits, it is giving correct result. right? It is not A or B, Chakrabarti. So you have to take complements of subtrahend, minuend and subtrahend. So A minus B. In that, you have to take complements of B only. Shubham Kumar Baranwal. I do not understand where you are asking that question. Which one? Just follow my words correctly. We know how to get 2's complement. I'll show you that, Annapurni. Wait. Here what we are doing? A minus B. A is less than B. That is confirmed result is negative. A and B are unsigned numbers. In this binary subtraction, I am using 2's complement and 1's complement method. Yes, confirm result is negative. Because by looking at numbers itself, we can say that result is negative because A is less than B. We need to prove that using methods, right? A, B. So A minus B. First, what we do? A plus 2's complement of B. In 2's complement method, 2's complement of B. So 0 as it is. See here. From here, right? We are taking 2's complement of B. 0 as it is, 1 as it is, complementing remaining bits 1, 1, 0. Right? Then adding these two is not producing final carry. Then confirming result is negative. Then how to get result? So magnitude we can get by taking 2's complement of sum and consider negative result. This is magnitude. See, this is 9 with respect to binary. 9 minus what we get here? 18. What is the result we are expecting? Minus 9. Yes, it is 9 minus. Am I right? It is 9. It is 18. 9 minus 18. Result must be minus 9. Result is negative. But how to get result? Take 2's complement of some magnitude we are getting and consider negative result. Again, here, what is that here? A directly. 1's complement of B, I am writing. 1's complement of B, what is that? 0, 1, 1, 0, 1. Adding 1 plus 1, 0, 1 is carry. 1 plus 0 plus 0, it is 1. 0 plus 1 is 1. 1 plus 1 is 0, 1 is carry. 1 plus 0 plus 0, it is 1. Again, there is no final carry. Are we getting final carry? No. Then take 1's complement of sum. So this is sum taking 1's complement of sum. How to get that? 1 to 0, 0 to 1, 1 to 0, 1 to 0, 0 to 1. Then consider negative result. Yes, it is minus 9. Yes, it is minus 9. Nagendra Thangeti. How can you subtract that? When you are subtracting, you need to swap the numbers. 3 minus 8, result is minus 5. How are you getting that? 8 minus 3, right? When you want to check the result directly, what is it here? 1, 0, 0, 1, 0. Swapping the number, subtracting. Right? Cannot be subtracted. Taking power, it becomes 2. 2 minus 1 is 1. What we have here? 0. 0 minus 0 is 0. What we have here? 0 minus 0 is 0. What we have here? 0 minus 1 cannot be subtracted. We are taking power, it becomes now 2. 2 minus 1 is what? 1. What else we have here? 0. Correct? Right? This is result. I am directly subtracting. When we are taking power, it becomes 1, 0 in binary. Decimal, it is 2. 2 minus 1, difference is 1. What we have here now? 0. Effectively, 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 1 cannot be subtracted. Taking borrow. Now it becomes 1, 0 in binary. Decimal, it is 2. 2 minus 1, again 1. What we have here? 0 and again 0. Nageshwarao. Not Nageshwarao, sorry. Someone was asking that. Nagendra. Right? Anil Kumar, when we are using in processor, advantage is we have sign flag. Sign flag. Result is an accumulator. Sign flag will be set or reset depending on result. In processor. Anil Kumar. And someone was asking about previous slide. This is previous slide. Applicable for all. Vamshi Krishna. Right. People are asking from day one about textbooks. Let me mention about textbooks. I suggest you my first preference is digital design by Wackerly. Next, modern digital electronics by R.P. Jain. And digital design by Maurice Mano. Many of you are asking about this, sir. Yes. Eleventh slide, 12th slide, 13th slide. And this is my WhatsApp number. This is my email ID. Do you need break? Yes, sir. Manisha.
Good afternoon, sir.
Good afternoon, ma'am. Tell me.
Sir, here in center we have to, we have to change the, we have to do one's complement after getting the value if we don't have any carry.
Yes.
Yeah, like that also, sir. If we don't, if we don't do any complement also, we can
It is
represent.
in complements form.
Yes, sir. We can
It is in
write this.
complements form. It is in signed representation.
Yes, sir. Then also we can leave that.
Yes.
We can leave that like that also, no, sir.
Yes, you can. You can. Yes.
Sir, and in the previous question, you have said like for 23 we have to no, not 23. Here one bit is less than the other bit, right, sir? In one question, you gave the bits, number of bits are unequal in the previous question.
Yes. Yes. Here.
Yeah, there we can do like the process. The process is firstly we have to like we have to complement the other the number which having negative sign, and we have to do sign extension, right, sir?
No. It is unsigned binary number.
Yes, sir.
Clearly mentioned, these numbers are unsigned binary numbers.
After doing the sir, after doing that complement, like
Right.
one's complement, two's complement, then
Please try.
yes,
Oh,
sir.
after taking two's complement, you want to do extension.
Yes, sir.
So initially itself, it must be applicable for other number systems also. Whatever I've been mentioning for other number systems also, I need to say this. For decimal number is there. I want to use this tens complement and nines complement method.
Yes, sir.
There.
Then we can't like
That's
we
what.
can't.
That is
do
even generic. I mentioned generic.
that. Okay.
Right.
Thank you, sir.
Thank you.
Hello, sir. In
Yeah,
11th
Navin.
frame,
Navin.
in 11th frame, according to the first sum, in B, I think, sir, A minus B right there, sir.
Yes,
In
B.
B, why haven't we added 0 instead of 1?
Unsigned binary numbers. I've been
This is the
mentioning these
concept.
words. Unsigned binary numbers. This is generic for all the number systems also.
So,
You are thinking about these numbers are signed numbers. I need to extend with MSB. No.
so,
Extending with MSB, taking two's complement will not be giving correct answer.
so this rule is exclusive to this as complement, the subtraction method only, right, sir?
Yes. Yes.
That is my doubt. Thank you, sir.
Right. Sri Lakshmi. Lakshmi. Right. Manisha.
Sir, I have some doubts other than this. Like sir, you gave
You
one.
can mail me or you can message me. I'll respond.
Okay. Okay.
Otherwise,
Thank
at the end, if you wait after 6:30 also, I'll wait. If you have doubts, we'll continue with that.
Okay, sir. Thank you.
Right? Instead of interrupting everyone's, right? Please
Okay.
wait till the end, or you can message me or you can mail me.
Okay, sir.
Right. One more thing for today. I'm taking off for today. So there won't be any continuation of class due to some personal reasons. So there won't be second session of this class for today. And tomorrow or day after tomorrow, I'll be covering with extra time. Be ready for that. So some personal reason I have to take off for this off session. Like 1 hour session is remaining. After taking break, it may be taking 1 hour continuously. So some other reasons I'm taking off If you don't have any doubts, sir, see you tomorrow.